All right, we're going to resume with problems 22 through 24. All right, we're asked to find the inverse of the one-to-one function. Find the inverse. So that means we're going to switch x and y, and then we're going to solve for the new y. Okay, and we have three different problems. Not that you're going to have three different problems of this type on the final exam. You will have one of these types of problems. So depending upon the version of the exam that you get will determine, which of these types of problems that you will have to find an answer for. So let's find the inverse of the one-to-one function. Let's start with 22. Okay, so I'm going to go ahead and replace f of x with y. And now I'm going to switch the x and y. So this this y becomes x, and that x becomes y. Okay, now we want to solve for the new y, and then we'll have the inverse function. So algebraically, to solve for the new y, we want to isolate y. So let's subtract an 8. We'll cancel here. Now let's line this up in a row format. So x minus 8 equals negative 8 times y. And let's divide by negative 8 to get y by itself. So put both these terms over negative 8. And those will divide out. And then I'm going to trade sides. I'm going to put y on the left. And then have my answer here. And then a lot of times what we did was we replaced this y so as not to confuse with the original y. We replaced that y with the inverse notation, which was f negative 1 of x equals this fraction. And I do want to mention that if this is not present there, if this form of the answer is not present, what are some other things we could do? Well, we could break this apart by putting negative 8 under each of these terms. So it might be that you see it something like this, x over negative 8, and then you might see minus, let's see, how do I want to do this? Minus 8 over another negative 8, which that would change to positives here if you think about negative divided by negative. So not sure quite what version you're going to have of the answer, but then if I simplify it, I'm going to have plus 1. So it's either that format or this format. They're equivalent, they're just written differently. Okay, let's look at another problem where we're finding an inverse. Sure, I can see that, 3x minus 1. So to find the inverse, let's replace f of x with y first. Now we're ready to switch the x and the y. Okay, to solve for the new y, our approach was when we have a situation like this with a fraction, we cross multiplied. So let's multiply x by both these terms. So 3xy, and then x times minus 1 is minus x equals, and the other cross product is 7. To solve for the new y, let's add this x to the other side. We don't need it over here. And we have 3xy equals, and we'll just put this in a row format. X plus 7 is usually, x is first usually. To get y by itself, I've got to divide by both 3 and x, and then divide by 3x here. So those 3x's will divide out. I'm going to go ahead and replace y with the inverse notation. Okay, and again here, look for that answer choice first, but if it's not there, perhaps they took this monomial, this one term, and put it underneath both the x and the 7. And then further cleaning this up, I could divide this x out with this x, leaving 1 on top. So another version of the answer might be 1/3 plus 7 over 3x. So not quite sure in the choices how they're presented to you, but either this is the answer or perhaps this is the answer here. Okay, and one more inverse function problem. I believe it was square root of x minus 8. It's still on x. I haven't switched yet. Now let's switch. To solve for the new y, I've got to square both sides. to get rid of that square root. So we have x squared equals the square and just the square root. We have y minus 8. And as a final algebraic step, let's just add the 8 to the other side. So this y I'll replace with the inverse notation. And then over here in a row, we'll put x squared plus 8. So that would be the answer. Right, the next group of problems says use the vertex and intercepts to sketch the graph of the quadratic function. Okay, we have quadratic functions because the highest degree exponent is 2. So we want to find the vertex and the intercepts, the x-intercepts, to sketch the graph of the function. All right, so on 25, yeah, I probably better do that on paper. So this quadratic is in what we call standard form because you have a parenthesis, and inside here you have two terms called a binomial square. So it's easy to identify the vertex of this parabola. So the vertex of this parabola is going to be +2 and -6. So at least right now I know that the vertex is at the ordered pair 2, -6. And I do also know, because I have a coefficient 3 that's positive up front here, that this parabola is going to open upward. So if I'm going to plot at least the vertex and get started, I'm going to plot over 2 and down 6. And I know my graph's going to open upward. So if I'm going to locate the x-intercepts, that's where we set the equation equal to 0. So I'm going to let f of x be 0 to find these x-intercepts. Okay, the easiest way to proceed through here, I would think, is to add the 6 to the other side first. Then I would divide by 3. This would result in 2. I'm isolating that binomial square because the next thing I'm going to do is I'm going to bring in the square root. So I'm going to bring in the square root on both sides of the equation. I can't simplify that, so I'll just bring down square root of 2, and we bring out x minus 2 within the absolute value. Bring out x minus 2. But don't forget this is an even power, so we have a possibility of 2 roots. I'm actually going to trade sides and put the absolute value over here. Okay, and our next move is to remove the absolute value, but we adjust to the plus minus over here. I'm going to come up here. Then I'm going to add 2 to both sides, and it's common practice to put that number in front of the plus minus. So let's see, I have x equals 2, I want to change sides, plus or minus square root of 2. So one x-intercept would be 2 minus square root of 2, and the other x-intercept is going to be 2 plus square root of 2. And I'm not sure if they'd be listed separately or if they'd be combined like that. All right, so we sketched it, we found the vertex, we found the x-intercepts, and so whatever decimal values these are right here, they would equate to whatever numbers these are. So you can find these decimals values on your calculator, and it would tell you what these x-intercepts are. And my graph was just real rough. It could be that, you know, my x-intercept falls over here. It's another positive number. It just could be my my graph, my sketch in the beginning was off a little. All right, 26, we want to do the same thing. We want to find the vertex and the x-intercepts, and then we want to sketch the graph. Well, the presentation of this quadratic equation is that we don't have it in this standard form. I can't identify what the vertex is easily. So we used another strategy for that problem. Let me get it copied over here, and then we'll look at that strategy for finding the vertex. Okay, in order for us to find the vertex here, I'm going to try and give myself some room here. The vertex was found by finding the x-coordinate of that vertex first, by finding -b over 2a. So let's go into the equation and identify our ABC values. Well, a is going to be the coefficient on the x squared term, so that's a. B was the coefficient on the linear term, so 5 is b. And c was our constant, the term that didn't have a variable. So opposite 5 over 2 times 1. So that's negative 5 halves. And the way for us to find the y-coordinate is we substituted negative 5 halves back into the function. So f of negative 5 halves. And I would go straight to the calculator on that one. And you would get negative 9/4. Or you might get the decimal negative 2.25. That's fine. All right, so our vertex, if we put it in vertex form, was negative 5 halves, comma negative 9/4, whether you used fractions or decimals. So we can kind of see where the vertex is. It's in the third quadrant. Let me do the x-intercepts first, and then we'll put it all together and get the graph. All right, the x-intercept is set the equation equal to 0. And I think I'm going to trade sides, and as I do so, I'm going to rearrange this polynomial. And how do we solve this? We factor. So we could do a factor sum chart if need be, as a reminder. Factors of a times c, 4, that sum to 5. And it looks like it's going to be 1 and 4 that add to 5. So this factors into 2 binomials. We have x and x up front to multiply and give us x squared, and then we have plus 4 and plus 1. And it doesn't matter if you have the 1 here and the 4 here. Set each factor equal to 0. So we have x equals negative 4 and x equals negative 1. So if we put all this together, let me see if I'm still on the screen here. Yep. I could locate the vertex first. It's left 2.5, so about right here, and then down 2 1/4. So it looks like about 2, so here, about here. The graph's going to open upward because I have a positive coefficient on the x squared term, and then my x-intercepts will occur at x equals negative 4 and x equals negative 1. Didn't do a good job drawing to scale, but that is the idea. So I don't know which form you're going to be given to identify the vertex. You're going to be given the standard form, which is easy to identify the vertex, or if you're given this general form of a quadratic where you have to actually use the little formula x equals opposite b over 2a, get an answer, plug it back into the original to get the y to complete the vertex. So I don't know which one, but we want to be prepared for both. Okay, let's look at the next group of problems and that objective. Use the leading coefficient test to determine the end behavior to graph the function. The leading coefficient test. Well, the leading term is negative 4x cubed because it's the term that has the highest exponent. And this is the problem where we responded with rises left or falls left, and then rises right or falls right. So for this particular problem, what we said was let's analyze the lead term. This has the most impact on the graph at the end behavior. These are all kind of chump change. They don't matter for this question. Okay. The negative 4x cubed determines how this graph is going to look on its ends. And what we did is we kind of compared this leading term to 4 situations, 4 cases, if you will. I think I'm going to go to paper so I can kind of show you those 4 cases, because again, you might not have negative 4x cubed. You might have negative 4x to the 4th, or you might have positive 4x cubed, or positive 4x to the 8th power. So we're looking at positive negativeness here, and we're looking at even or oddness here to determine the rising falling situation. All right, so lead coefficient test, grab the lead term. So this is 27. Okay, when we were answering these kinds of questions, we wanted to really analyze the lead term and compare it to one of 4 situations. Which of these 4 situations does that lead term most closely resemble? So real quickly, 4 graphs is what we looked at. We looked at y equals positive x, positive 1, x to the first. We looked at y equals negative x, negative to the first power. We looked at a graph of y equals x squared and y equals negative x squared. These are the 4 cases that we used to help us determine the answer to this question. So y equals x, looks something like this. We fall left, rise right. Negative x is in the opposite direction. Rises left, falls right. Y equals x squared is rises, rises on the left and right. And negative x squared is falls, falls. So even exponents are in behaviors in the same direction. If we have a negative coefficient, then we fall. If we have a positive coefficient, we rise. On y equals 1x, if we have a positive coefficient and an odd exponent, we fall left, rise right. And if we have a negative coefficient with an odd exponent, we rise and fall. So for 27, our lead coefficient was y equals negative 4x cubed. So of these four cases, I'm going to first look at the exponent, and I'm going to go, oh, that's odd. So these two cases would be out. Then I see of the remaining two cases that I have a negative coefficient, so I'm going to equate negative 4x cubes and behavior to the end behavior of y equals negative x. So my response on 27 would be rises left, falls right. Okay, now what if your lead term was y equals 2x to the fourth? We're done with this problem, but I just want to make sure that we're not isolating our look at just this case right here, because not all the answers are going to be rise left, falls right. If you had a lead term of 2x to the fourth with some other chump change in there, so to speak, what case of these four presented would this end behavior most closely resemble? Well, even exponent means these two cases are out. Positive coefficient, 2, would equate to y equals x squared. My response would be my end behavior is rises left, rises right. And I only covered 2 of the 4 cases, but hopefully you can kind of see what it would take in a lead term to get to the remaining 2 cases. Okay, next group of problems. We have 3 within here. Not that you're going to have 3 of the same type. You're going to have one of these types of problems on your exam, but we want to be prepared for which one you have. Okay. So take a moment and read through the instructions there and kind of get our mind around what we're finding. All right, we're finding the zeros. So we're going to replace all f of x's with 0 and set the equations equal to 0. You should expect that your equation, whichever one you get, should already be in factored form, so we don't have to do that complicated factoring. So we're going to set the equations equal to 0, set each factor equal to 0, and then we're going to discuss the multiplicity and whether we touch or cross the x-axis, depending upon that multiplicity. So for 28, I'm going to jump off that problem, and I'm going to go ahead and set it equal to, jump off that problem from the worksheet onto the paper, set the equation equal to 0. I have a factor of 3, I have a factor of x plus 2, and I have a factor of x plus 3 to the third. So I drew these little vertical bars here to show us where we're going to separate the factors. So I'm going to set 3 equal to 0. Well, there's no variable here. That's a false statement. 3 does not equal 0. So I don't get any answers from this factor without a variable. So x plus 2 is a factor, subtracted 2, that means negative 2, x equals negative 2 is a 0. Well, what's the multiplicity? Well, that depends upon the outside exponent. The multiplicity is 1, that's odd, and when we have odd multiplicity, we cross the x-axis. Even multiplicity means that we touch the x-axis and turn around. All right, this factor right here, now you could write out 3 of these, but it's really not necessary. I mean, that 3 exponent means that you have 3x plus 3 factors. Well, that'd be a lot of work to do, and I don't need to do that, so I'm just going to set x plus 3 to the third equal to 0. I can cube root both sides. And I'm left with no absolute value, x plus 3 equals 0. And maybe you saw that from way back up here. Subtracted 3. So what's the multiplicity? Well, we go back and we look at the exponent on that factor. And so the multiplicity is odd. It's 3. And so we're going to also cross. We used this information in previous lessons to help us sketch a graph of a function. We plotted the zeros, and then we either went through the crossed through the x-axis or we touched it and bumped off of it. All right, let's look at 29. Wait, I'm on the camera. Here we go, 0. Okay, probably something important to kind of point out here is that this square is going to determine our multiplicity. This square is on the outside of this binomial. However, look at this square. It's not on the outside of our parenthesis. There's really an understood 1 here. So how we handle this might be a little different than what we've been doing in the previous example and what we're going to do here. Okay, let's set each factor equal to 0. So set 5 equal to 0, but that's false. That's fake. So no zeros come from there. X squared minus 4 equals 0. You could add the 4 and square root both sides, or x squared minus 4 does factor into x minus 2, x plus 2. Set each of these factors equal to 0, and notice their multiplicities are both 1 for those parentheses. So one 0 that results is x equals 2, and the other 0 that results from this factor is x equals negative 2. And the multiplicity for both of those are 1, so we would cross at each of those x values. All right, x plus 1, quantity squared equals 0. I'm going to bring in an even root. So square root both sides. X plus 1 comes out, but it does require an absolute value. This is 0. Remove the absolute value, making this plus minus 0, which is just still 0. Subtract a 1. So what zeroes out this factor is x equals negative 1. So the multiplicity is 2. And so we're going to touch at that 0. Touches. Okay. And then I think I'm going to leave 30. You have the idea and hopefully a reminder of how to find zeros and multiplicities and discussing whether a graph crosses the x-axis or touches the x-axis at each of those zeros. So I'll leave 30 there. Of course, I'll have office hours too before the final. So if you're struggling with 30, we can certainly talk then as well. Let's go to the next group of problems. All right, find a rational 0. This is going to be our P over Q list. If I'm remembering correctly on the final exam, you are actually given a rational 0 and asked to use that rational 0 with synthetic division to find all the other zeros. But for this one, you weren't given one of the rational zeros. We're asked to find it, find all the zeros of the function. So let's take a look at 31. This is going to require some work, so I'm back to the notebook paper. Give me a second to write that down. Okay, so find a rational 0. So first of all, we have to get our list of possible rational zeros, and that comes from finding the factors of P, the constant, and dividing the factors of P, the constant, by all the factors of Q, the coefficient on the lead term. So we came down here and we started thinking about 8. 8's factors are plus minus, and you can put the plus minus in front of each of the factors individually or kind of house it out here. 1 goes into 8, 2 goes into 8, 4 and 8 divide into 8. And the factors of Q, well, the factors of 3 are just 1 and 3. Now what we did is we created our P divided by Q list. So we took every P and put it over every Q. So for this one, we're going to take 1 and put it over 1, and then we're going to take 1 and put it over 3. So I've got 1 over 1 and 1 over 3. So that's 1 over 1 is just 1. And then 1/3. And I think I'm going to do this plus minus out front here. Then take 2 and put it over 1 and take 2 and put it over 3. So that's 2, and then that's going to be 2/3. Put 4 over 1, get 4. Put 4 over 3, get 4/3. 8 over 1 is 8, and 8 over 3 is 8/3. Okay, so that is a list of possible rational zeros there. And then we had to actually go through and figure out, of all these different numbers, positive, negative, which one of these would give us a 0 in synthetic division. Well, I'm going to cut right to the chase, and I'm going to tell you it's 2. 2 will be a rational 0 for this function. So we put 2 in this little kind of box up here in the upper left-hand corner. We wrote down the coefficients of all the terms, including the constant. We filled in any zeros for any missing terms up here. I see I have a 3, 2, 1 down to a constant. Had I been missing any of these, I would fill in a blank 0. We skipped a line, drew a line, and then we brought the 3 down. 3 times 2 is 6. We added down again, negative 11, multiplied, negative 22. Used our calculator, got negative 4. Negative 4 times 2 is negative 8. And when we got a 0 here at the end, we knew that 2 is a root or a 0 of this cubic. Okay. But we can't stop there. It said then use that rational 0 to find all the other zeros. Well, you might remember that n stands for the highest degree. So these are the coefficients of a cubic, but when you divide out here one time a linear factor, we're going to get coefficients of a quadratic. So let's take these coefficients and make it a quadratic equation. 3x squared minus 11x minus 4. Let's set that quadratic equation equal to 0, and then factor this to get the other two zeros. Whew, there's a lot here. All right, we can try and factor this, or you can go right to the quadratic formula, whatever you choose. As a reminder for this, I probably would do a factor sum chart. So I need factors of negative 12 that sum to negative 11. And because this coefficient is greater than 1, I am going to have to do factor by grouping. So factors of 12 are 1 and 12, 2 and 6, 3 and 4. I need one of these factors to be negative, the bigger one to be negative, to sum to negative 11. So it looks like it's going to be 1 plus negative 12, and that will give us negative 11. So it's been a long time since we factored by grouping, so what we want to do with these factors are break up this middle term into the sum of two other terms that result in negative 11x. So we kept the first term. I'm going to put minus 12x first. I like to put the negative number first, plus 1x, and then bring down the last term, minus 4. And then we continued with factor by grouping. Now this is a plus here, so when I put this parentheses, I don't have to change that sign. And I could keep a 1 in front here. Let's take out a common factor. Well, 3x will come out here. Let's skip a line to kind of clean that up. X minus 4. And then there is an understood 1 there. And remember that the result of trying to factor by grouping is that we get the same parenthesis. Because now we want to take out that common parenthesis. And when we factor it out, we're left with 3x and the plus 1. Set each factor equal to 0. So the 0 here would be positive 4. And then set this factor equal to 0. I'm going to subtract a 1 and divide by 3. So all of our zeros, we should have 3 of them because we have a cubic, would be x equals 4, x equals negative 1/3. Oh, I'm so sorry. And then the first one that we started with was x equals 2. Whew. All right, I believe we have more of the same problems here. So I don't think I'm going to do all those. Just the same procedure, creating a list of P's and Q's, and then finding those P over Q values, and then using synthetic division, and then finding the remaining zeros. What's interesting about 33, I'm not sure if you'll have one like this. I kind of hope you don't, but notice that it's a fourth degree function here, power of 4. You're actually going to have to do synthetic division twice to go from a fourth degree down to a third degree down to a second degree to get to that quadratic that you could either factor or use quadratic formula. So you might want to kind of attempt those, or at least use the worked out solutions to kind of help guide you through that. I believe though on the final exam, the good news is that I think you are given a rational 0. And so for what that means is you just enter into the problem right at synthetic division. And hopefully it'll be a cubic and you'll be given a rational 0, and you can do one synthetic division to get to a quadratic and then either factor or use quadratic formula. Of course, always know it's multiple choice. Another strategy is the backwards strategy. Take the answer choices, plug them back into the problem, and see which one works. Okay, if you can avoid any of the work, if it's going to be a multiple choice test. Okay, it's always a good strategy to work backwards. Okay, we need to move on. Let's look at, well, again, I think I'm going to stop there. This video is in excess of 30 minutes. So we'll pick up in the next one with starting with number 34.